We would like to graph this hyperbola as well as determine the center, the vertices, and the equations for the asymptotes. So first, just a reminder why it is a hyperbola at all. The first giveaway is that we have subtraction here. So when you have a conic section in this form and you have subtraction, you're going to know immediately that it's a hyperbola. And it might have thrown you off that these denominators were actually the same. They're both 16. But remember, it would only be a circle if we had addition here in the center. If this was an addition problem and both of the denominators were 16, then it indeed would be a circle. But because we have subtraction, that tells us that we actually have a hyperbola. So if we have a hyperbola, remember that in this form, we know that a squared is our value that is first. So a squared is 16, therefore a is equal to 4. And because x is first, that tells us that we have a horizontal hyperbola. In other words, it's going to have a horizontal transverse axis. And before we get into graphing it, we need to know where the center is. So you'll notice that we have an x minus 2 as in my first quantity. So that's going to be a shift to the right 2. And then over here, my y value does not have any values added or subtracted to it or from it. So there's not going to be any vertical shift. So we're simply shifting to the right 2. And we're not shifting anywhere up or down, so my center would be at 2, 0. So let's go ahead and begin generating our graph. So right 2, 2, 0, here's the center of our hyperbola. And then we know that because the a value was 4, and we've already decided that it is a horizontal hyperbola, then from the center I'll travel to the right 4 units, and that will be one of my vertices. And then to the left 4 units to get to my second vertex point. So we could go ahead and label my vertices. So if we were at an x value of 2, but we just traveled to the right a distance of 4, then we know my new x value would be 6, and the y value hasn't changed. And likewise, if I'm at 2 and I travel to the left a distance of 4, that would be 2 minus 4, so my second vertex would be at negative 2, 0. Alright, so now to graph the rest of the hyperbola, we want to graph the asymptotes. And remember, this is where we're going to use our b value. So by process of elimination, the other denominator is my b squared. So b squared is equal to 16, so b is equal to 4. So now this is the distance that I'm going to be traveling from the center up and down. So I'll travel up a distance of 4 from the center. And again, if it was an ellipse, you would actually put an ordered pair here. You'd actually draw in a coordinate. But instead, because there's not actually a point here, remember this is just going to help us draw in this central rectangle. So I'm just going to draw kind of a horizontal line. And then from the center, I'll travel down a distance of 4. And also draw in a horizontal line. And then I will draw vertical lines where I had my vertices, and then just extend these vertical and horizontal lines until they meet, creating what we call the central rectangle, which in this case actually is a square, since A is 4 as well as B. A and B are both 4. So then if I connect the corners of this rectangle or this box and the center using a straight edge would be great. If I connect the corners, then I have my asymptotes. So the corner of the box, the center, and the other corner. You can see mine is definitely not drawn very well. Graph paper would be excellent. And that's enough to draw your hyperbola. So remember, it has to pass through the vertex that we've graphed, and then it's going to approach my asymptotes. It's going to get very close to them. And there's the branch that's opening to the right. And then here's the branch that's opening to the left. So we have our center, we have our vertices, and lastly we want to find our asymptotes. We've drawn them, but we want the equation for these asymptotes. So remember, starting at the center, if you were to count your rise and your run, we went up a distance of 4 units, and then we went to the right a distance of 4 units. So the slope of my first branch is going to be 4 divided by 4, rise and run, which is really a slope of 1. And then likewise, if we look at the other asymptote, we went down a distance of 4 units and right, but because we went down, that'd be in the negative direction. So the slope of my other asymptote would be negative 4 over 4, which is negative 1. But we want to actually write the equation for the asymptotes as lines, and we know we can use y equals mx plus b, or we could use point slope form. So a great review of point slope in case you need it. Here's your point slope. So either one, I'm going to go ahead and use point slope form. Since I know the slope, and if you take a look at your diagram, remember that both of your asymptotes are going to pass through the center point. So I can use the point 2, 0 as my point. So, for example, if my slope is positive 1 and the point was 2, 0, then the point slope form of this line would be y minus 0 is equal to 1 times the quantity x minus 2. In other words, my line is y equals x minus 2. This would be the equation for one of the asymptotes, the one that has a positive slope. And then the other asymptote has a slope of negative 1, but it also passes through the center, so we can still use the point of 2, 0. So point slope form, y minus 0, equals negative 1 times the quantity x minus 2. Simplifying, we have y equals negative x plus 2. So this would be the equation for my second asymptote, the one that has a negative slope. And we're done.